In the vast expanse of our cosmos, where billions of stars twinkle in the darkness, there exists a titan among them, a celestial body so enormous, so magnificent, that it challenges our understanding of what's possible in the universe. This is the story of Vicanis Majoris, one of the most extraordinary stars ever discovered. Welcome back, stargazers and cosmic explorers. Today we're venturing into the realm of stellar giants, where the physics of our universe creates astronomical wonders that defy imagination. I'm absolutely thrilled to take you on this journey to explore a star so massive that if placed in our solar system, it would engulf everything from Mercury to beyond Jupiter, potentially reaching Saturn's orbit. Vicanis Majoris isn't just big, it's a dynamic, pulsating cosmic engine that gives us crucial insights into the life cycle of massive stars and the very processes that created the elements that make up our bodies and our world. As we gaze up at this red supergiant located in the constellation Canis Major, we're witnessing a stellar titan in its twilight years, a glimpse into the future fate of many stars in our universe. So sit back, look up, and prepare to have your mind expanded as we explore the mysteries, the science, and the sheer wonder of Vicanis Majoris, the cosmic giant that continues to captivate astronomers and stargazers alike. At approximately 640 light-years from Earth, Vicanis Majoris sits in the constellation Canis Major, far enough that its light takes over 6 centuries to reach us, yet close enough to be one of the brightest objects in our night sky. Think about that for a moment. The light you see when you look at Vicanis Majoris tonight left that star before Galileo first pointed his telescope at the heavens. The first recorded observations of this stellar giant date back to ancient civilizations. Ancient Greek astronomers noted this unusually bright red star in their celestial catalogues, giving it a name that roughly translates to the burning red dog star due to its position in the Canis, dog, constellation. However, it wasn't until the 18th century that astronomers began to suspect there was something extraordinary about this particular star. In 1783, renowned astronomer William Herschel made detailed observations of Vicanis Majoris, noting its unusual brightness variations. But the true nature of this cosmic behemoth wasn't fully understood until the early 20th century, when advances in spectroscopy allowed astronomers to analyze its light in unprecedented detail. The breakthrough came in 1921 when astronomer Annie Jump Cannon, while working on the Harvard classification scheme, identified Vicanis Majoris as an M-class supergiant, one of the largest types of stars in the universe. Her work laid the foundation for our modern understanding of this stellar titan. Today, powerful observatories like the Hubble Space Telescope and ground-based facilities equipped with adaptive optics have revealed Vicanis Majoris in stunning detail, showing us not just a point of light, but a complex, dynamic system with surface features larger than our entire solar system. Let's try to comprehend the incomprehensible scale of Vicanis Majoris. With a radius approximately 1,500 times that of our Sun, this cosmic titan encompasses a volume that could fit over 3 billion suns inside it. If our Sun were the size of a golf ball, Vicanis Majoris would be the height of a 40-story skyscraper. To put this in perspective for our solar system, if we placed Vicanis Majoris at the center where our Sun currently sits, its surface would extend beyond the orbit of Jupiter, possibly reaching Saturn. The Earth, Mars, and the inner planets would be deep inside the star itself, completely engulfed by its immense bulk. But size isn't the only impressive aspect of this star. Its mass is estimated to be around 17 to 19 times that of our Sun. Despite having a mass many times greater than our Sun, Vicanis Majoris has an incredibly low density overall. The outer regions of this supergiant are so diffuse that they're more like a hot vacuum than what we typically think of as stellar material. If you could somehow fly a spacecraft through the outermost layers of Vicanis Majoris, which would be impossible due to the heat, you might not even realize you were inside a star. That's how tenuous these outer regions are. The gravity at the surface of Vicanis Majoris is surprisingly weak for such a massive object, another consequence of its enormous size. While the star's total gravitational pull is immense, at its surface, which is defined as the visible photosphere, the gravity is estimated to be just a fraction of what we experience on Earth. This weak surface gravity is one reason why the star loses mass so rapidly. Material can easily escape from its gravitational embrace. Speaking of mass loss, Vicanis Majoris is shedding material at an astonishing rate, approximately 10 to the power of -6 solar masses per year. That translates to the star losing an Earth's worth of material roughly every 500,000 years. This stellar wind creates a vast envelope of gas and dust surrounding the star, extending for trillions of miles into space. To understand Vicanis Majoris as it exists today, we need to understand the life cycle of massive stars. Unlike our Sun, which will live for about 10 billion years, stars like Vicanis Majoris burn through their nuclear fuel at a prodigious rate. Kindly like, share and subscribe our channel for further more updates about space.